Hi children, how are you? I hope you are fine. Okay, now I am going to explain the topic classification of elements and periodic table. Dear children, I want to share one thing with you. Before coming to here, I met my old student. I observed his bag. He arranged his books in different racks, means textbooks in one rack, notebooks in one rack, and stationaries in one rack. When I asked him a question, why do you arrange like this? He answered me that it is very easy to find those books. It is very interesting, isn't it? So, it is a good example of classification of elements. I want to give one more example. When you go to a medical shop, we can see there are vast number of medicines in it. It is very difficult to remember all the names of the medicines for the shopkeeper. But when you ask him for a particular medicine, he hands over it to you without any difficulty. What makes him easy? Means already he arranged those medicines in a particular order. It makes him easy. One more example. When you go to a supermarket, we can see there different types of goods arranged in different areas. So, it makes us easy to find the things and to collect the things what we needed. So, from these observations, we can understand one thing, that any system involving several things needs a particular order of arrangement. Even in chemistry, from the earliest time, scientists have been trying to classify the elements according to their properties. Okay, in front of us some questions are there. First of all, what is an element? Who defined the term an element? How many elements were discovered? Okay, let us go to history. What is an element? An element is the substance that cannot be decomposed into a further simple substance by physical and chemical change. That means the substance which cannot be divisible into further simple substance is called an element. And it is the fundamental material in which all matter. This is given by Robert Boyle. Do you know how many elements are discovered? So at the time of Robert Boyle, there were 13 elements discovered. And in 18th century, at the time of Lavoisier, 11 more elements were discovered. Totally 24 elements were discovered at the time of Lavoisier. Now in 19th century, 63 elements were discovered. And in 20th century, by 1940, 91 natural elements were discovered and 17 artificial or man-made elements were discovered. And now, there are more than 115 elements. When you look into Wikipedia, we can find there 118 elements by 2018. But in our textbook, we have that more than 115 elements. Whatever it may be, as the number increased, it is very difficult to remember all the properties of elements and their compounds. So that is why it is very essential to classify the elements according to their properties. Okay, again I will ask you one question. Who classified the elements at first? Dobrina, a great scientist, classified the elements at first. He was the first person to classify the elements. He classified the elements into groups. He arranged the elements in ascending order of their atomic weights. He proposed a law that is called Dobrina's law of triad. Triad means a group of three. Means every triad contains three elements. And what is the statement? The law states that the atomic weight of the middle element is the average of atomic weight of first and third element. That means when the elements are arranged in ascending order of their atomic weight of the middle element is equal to the average of atomic weight of first and third element. So that is given by Dobrina's. That law is called Dobrina's law of triad. Here some examples are there. Chlorine, bromine, iodine. These three belongs to one triad. Lithium, sodium, potassium. These three elements belongs to one triad. Calcium, strontium and barium. These three also belongs to one more triad. Okay, have a look here. Here some groups of some triads are there. First triad it is lithium, sodium and potassium. The atomic weight of lithium is 7. The atomic weight of sodium is 23. The atomic weight of potassium is 39. So, the average of atomic weight of first and third element, when you find here 23. So, it is accurately equal to the atomic weight of the middle element. So, according to Dobereiner's law, this triad is proved. And let us go to second triad, calcium, strontium and barium. The atomic weight of calcium is 40 and the atomic weight of strontium is 87.5 and the atomic weight of barium is 37. When you find the average of atomic weight of first and third element, we get here 88.5. So this is approximately equal to the middle element strontium but not accurately equal to the middle element. Let us go to third triad, chlorine, bromine and iodine. Atomic weight of chlorine is 35.5. Atomic weight of bromine is 80. Atomic weight of iodine is 127 units. When you find the average of first and third elements, we get here 81.25. This is also approximately equal to the atomic weight of the middle element, that is bromium. So that means from these observations we can understand one thing. That means atomic weight of the middle element is equal to the average of atomic weight of first and third element. This is given by Dobereiner. So that is why this law is called Dobereiner's law of triads. But do you know, this law was not valid. But it led to tremendous changes in the classification of elements and periodic table. This law was not valid due to some limitations. What are those limitations? First limitation, it is all the known elements cannot be arranged in the form of triads. At the time of Dobereiner, there were 53 elements discovered. He could not arrange all those elements in the form of triads. He arranged only few elements in the form of triads. That is one limitation. And one more limitation, this law is not valid for the low mass and high mass elements. That means low mass elements couldn't be arranged in the form of triads. High mass elements also couldn't be arranged in the form of triads. That is also one limitation from Dobereiner's law of triad. One more limitation it is, as the techniques improved to measure the accurately atomic weight, the law is not valid. These are the limitations from the Dobereiner's law of triad. This law was not succeeded, but it led to tremendous changes in the classification of elements and periodic table. After Dobereiner, one more chemist, Newland, came to classify the elements according to their properties. He arranged all the elements according to their atomic weights. He made groups. He proposed a law that is called Newland's law of octaves. Octa means 8. Means here the definition is there. The every 8th element starting from the given element resembles in its properties to that of first element. That means when the elements are arranged in ascending order of their atomic weights, every 8th element starting from the given element have the similar chemical properties to that of first element. Do you know this attempt to link to the properties of elements with the periodicity of the musical notes. As we know, in Indian system there are 7 musical notes. Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. So 8th note as same as the first note. This 8th note has the same characteristics to that of first note Sa. That means 8th note and first note has the similar characteristics. And also this 8th note is the starting note to the next scale. Like this, in this octaves law, every 8th element has the similar chemical properties to that of first element. It is given by Newland's. The law it is called law of octaves. Do you know, children? He was the first person to assign the numbers to the elements. Here it is the table, Newland's table of elements. He arranged 56 elements. He arranged all the 56 elements in the form of table. he arranged groups according to Newlands. These horizontal rows are called groups. He arranged in 7 groups. Okay, when we start from first element, every 8th element has the similar chemical properties. Can we start from hydrogen first element? Let us count. 1, 2, 3, 4, 5, 6, 7 and 8th. 8th element it is fluorine. So fluorine has the similar chemical properties to that of hydrogen. When we start from again from fluorine, 1, 2, 3, 4, 5, 6, 7 and 8th it is chlorine. According to Newlands, chlorine has the similar chemical properties to that of first element fluorine. Fluorine also has the similar characteristics to that of hydrogen. That is why he arranged these elements in the particular group. So according to Newlands, these elements have the similar chemical properties. When we start from lithium, 1, 2, 3, 4, 5, 6, 7 and 8th element it is the sodium. Sodium has the similar characteristics to that of lithium. That is why he arranged these elements in second group. According to Newlands, every group contained elements have the similar chemical properties. Do you know this law also not valid due to some limitations? What are those limitations? First limitation, it is instances 2 elements fitted in a single slot. That means two elements are fitted in the same slot. For example, here cobalt and nickel and platinum and iridium are fitted in the same slots. That means every element needs a particular space for it. They need a particular individual slot for it. But he couldn't arrange like that. He fitted two elements in a single slot. That is first mistake. And second one, it is certain elements with dissimilar elements arranged in the same group. For example, except hydrogen, fluorine, chlorine, bromine and iodine, those belongs to halogen family. When you observe here, cobalt, nickel, palladium and platinum, iridium have the dissimilar properties with compared to halogens. But he arranged all those dissimilar elements in the same group. That is why this is also one limitation from the Newlands law of octaves. It is good for only up to calcium. That means this law of octaves is only good for up to calcium, from hydrogen to calcium. Because these elements have the low atomic mass. Above calcium, these elements have high masses. So this law is not valid for high mass elements. This law is only valid for up to calcium, from hydrogen to calcium. And one more limitation, it is no space for new elements. He couldn't leave any space for the new elements which would be discovered later. That is also one limitation from the Newlands law of octaves. Okay children. This is the assignment for you. First question, what is an element? An element is a substance that cannot be divisible into further simple substance is called an element. Next question, who classified the elements at first? Dobereiner classified the elements at first. And state the law of Dobereiner's law of triads. Means when the elements are arranged in ascending order of their atomic weight, the atomic weight of the middle element is equal to the average of atomic weight of first and third element. Now how many elements are discovered by now? By now there are more than 115 elements were discovered. What is the first element? The first element is hydrogen, which has no neutrons. Hydrogen is the first element. Name some triads and prove the Dobereiner's law of triads. Lithium, sodium, potassium. These three belongs to one triad. And also we proved the law. Who assigned the numbers to the elements? Newland assigned the numbers to the elements at first. State the law of octaves. Means when the elements are arranged in ascending order of their atomic weight, every 8th element starting from a given element has the similar chemical properties to that of first element. It is given by Newland. That is why it is called Newland's law of octaves. Next, what is the necessity of classify the elements? As the number increased, it is very difficult to remember the properties of elements and their compounds. So that is why it is very essential to classify the elements according to their properties. Name some elements which are fitted in a single slot. Cobalt and nickel fitted in a single slot, and platinum and iridium also fitted in a single slot. These are the some examples of elements which are fitted in a single slot. So this is the assignment for you. You have to do it. Can you make it? All the best. Thank you.